Okay, we can start. One small point, technical note before we start. I've been asked again by people in the other class to post what I'm writing here. Sorry, what I'm writing here typically on the screen. I'm available for that for posting. The only point I want to make clear is that I've done that only 1 year due to students' pressure, and it was the year with the worst performance ever of everybody in the exam, because the consequence on a behavioral side was that people start stopping taking notes, saying, I'm going to get the slides and I'm fine. Clearly, I'm writing 10% of what I'm saying. So if you had to review, my suggestion, given that you have recorded videos, is at most see the recorded videos. Still, consenting to the request I had, I will post them. But my suggestion is, if there are parts which are unclear, go on the video, because there is far more than what is written. Okay. Having said that, I will I will post them week by week. Now, the part where we ended up last time was we were close to finishing the topic of the delta. The part that was missing was just one and simple. We have seen how we can define a portfolio delta overall, and we've seen that in the case of options on the Bund future, where I can summarize my position saying I'm overall, as here, short 2.10 future contracts, so that potentially I could do delta hedging by buying 2.10 future contracts. However, this is okay whenever you are trading options on a traded market, and so you have a standard size for the contract. For instance, here you know that one call and one put can buy or sell one future contract. How do things work when you are working on the over-the-counter, on the OTC market, in which you do bilateral deals that can have a different size from each other? Let us make an example. Imagine that you are trading options on currencies, and your position is made up by the fact that you have bought a call option on US dollars, having a delta of 0.8 and a notional size of the contract of 100,000 US dollars. This is the first position. The second position is that you have also sold a call on US dollars with a delta equal to 0.4 and a size of the contract which is now 300,000 US dollars. Okay? So the problem here is that the first contract has a higher delta, but at the same time has a smaller size. And you must consider clearly both things all together if you want to understand whether overall you are bullish on the dollar, as the first position is, or bearish on the dollar, as the second position is. Okay? Now, how can you understand overall which is your exposure? Here, the only possible transformation into an equivalent is to transform that into a cash equivalent. And the idea is the following. Here, you have a delta of 0.8. The delta of 0.8, or if you want, 80%, means what? Means that the premium of the option reacts 80% of the underlying, or the change of the price of the underlying. Is that okay? If you have a delta of 0.8, it means that the reaction on the option premium is just 0.8 times, or 80%, of what is going to be the change in the price of the underlying. So is this position more or less risky than buying cash $100,000? If you have a call option delta 0.8 and you have not bought directly $100,000, the position is less risky. Why? Because your reactivity is only 80%. intuitively, your position is equivalent to having purchased $80,000. So it's equivalent to having purchased 80% of 100,000. That's the intuition. Have I been clear? So the way in which you transform the position into a delta equivalent meaning an equivalent position on the underlying translated through the delta, okay? So an equivalent calculated through the delta, if you wish, would be to say this is as if I had a long position on 80,000 US dollars, okay? Because the size is 100,000, I only have a sensitivity at 80%. If we model in the same way the second contract, what can we say? The second contract in which you sell a call option is a bullish or a bearish position on the dollar. If you sell a call, it's a bearish position on the dollar. And has only 40% of the sensitivity as opposed to having sold 300,000 euros. So the equivalent is 0.4 multiplied by, attention, minus $300,000. Why minus? Because I sell the option. So the position is short the dollar, not long, okay? That's the only part. In the previous case, when you had contracts, we had delta times the number of contracts, where the number was negative if we sell. Here, if we sell, we have a negative notional, okay? That's the point. So for instance, if I were selling a put option, I would have a negative delta of the put option times a negative notional and overall a positive position, positive delta position, as it is if I sell a put, okay? So here, we would have a delta equivalent position of minus 120,000 US dollars, meaning that the overall delta of the portfolio would be minus 40,000, okay? So, for instance, here, if we wanted to delta hedge, delta hedging would imply to either buy spot or buy forward $40,000. In this way, I would bring the delta to 0, okay? That's the story. Sorry, it's a small extra, but typically discuss only the first case, whereas instead this is what happens on currencies typically, and also, for instance, on equity options traded over the counter. Maybe you make a big deal with an institutional investor for a large size, and then a smaller deal with a smaller investor for a smaller size, and you have to aggregate. That's the only way in which you can possibly do that, okay? All right, this closes the part on delta, and we can move to the second level of the game, which is looking at gamma. Let me introduce it a bit more formally this time. We have seen that when I want to model the change in a variable with a Taylor-Maclaurin expansion, if I model that just up to the first order, the change in a variable f, when I move from x0 to x0 plus h, can be written as the first derivative multiplied by the shock in the dependent variable. And we have seen on Tuesday that this is why we can write that the change in the market value of the option, which is my dependent variable f, is approximately given by delta times the shock in the price of the underlying, okay? So saying that delta market value of the option is roughly delta times the change in the price of the underlying is just a first order Taylor-Maclaurin approximation. As usual, on Tuesday evening, I received many emails by many of you who are fans of the second order Taylor-Maclaurin approximation, which is what we are going to do next if we want to be more precise. If we extended that to the second order term would be the second derivative taken in x0, divided by 2, and multiplied by h squared. And in the case of options, This is equivalent to adding gamma, which is exactly the second derivative, divided by 2, and multiplied by the change in the price of the underlying squared. Okay, so gamma is the second derivative, and if you want, you can see that as a way to better understand how your portfolio value is changing, because you're not just approximating that linearly, but you're taking into account a parabolic function, essentially, if you take into account the square root, the square of delta P in your estimate. But I want to explain the story better economically before than that. So the intuition about why gamma matters, first of all, can be explained in a super simple manner, which is the following. Imagine for a second you compare a long at the money call position with a short at the money put position. Consider for a second which is going to be the delta of each of the two positions. By saying the delta of the position, I mean not just the delta of the option, but the delta of the option considering whether I buy or sell, okay? So when you buy an at the money call, which is your delta? The delta of the at the money call is equal to 0.5. Since we buy, here we have 0.5 times 1, which is 0.5, okay? Now, let us look at the short put option. An at the money put option has a delta which is equal to what? Minus 0.5, correct? And since we sell, we multiply that by minus 1. So if I look at the delta only, these two positions are identical, okay? In the unlikely case there is anybody in the class or connected at home who is where he is going to spend the 2 years in the Master of Science in Finance without ever time going over and beyond the first derivative, this guy will say they are identical. Why these two positions are not identical is pretty simple if we think about exactly what's happening at maturity in the two. So imagine we get back, but just for a couple of minutes, not more than that, to a basic undergraduate course in which the enthusiastic professor shows you the first time the P&L of a long call and the short put. I cannot have the same level of enthusiasm, but I'll try. The P&L of the long call would be made up in this way. Below the strike price, you lose the premium. For a final price greater than K, you start exercising and you have a growing profit, okay? When you have a short put, with the short put, you make your maximum profit for a price greater than the strike at maturity because you get the premium, and it's wonderful. The bad news is that if the price at maturity is below the strike, you start having the exercise and potentially you lose a lot of money, okay? So these two positions having the same delta have a slight difference between the two because in the case of the long call, you have unlimited profits and limited losses. In the case of the short put, is the other way around, okay? Now, let me ask you one thing. Imagine we want to draw the P&L not at maturity, as in the boring undergrad course, but looking at the P&L today, when the option has time value and it is still distant from maturity. How can we do that? Super simple intuition. Think at the long call case. We have seen that the value of the call is represented by this orange curve, okay? But this was the graph of the value, not the P&L. If I want to move from the value to the P&L, what should I do? Should be to deduct the premium. So I have intuitively the same graph, simply taken down by a given amount, and this applies to both. Is that okay? So intuitively, the graph of the P&L you would have would be the following. Okay? What is going to happen in the case of the put option? For the put option, we have seen that the long put option would work in that way. So if I took into account the premium, the put option would give me this kind of graph. Is that okay? What is the position of the short put option? The answer is pretty simple. Imagine you have the guy with the long put option that makes a profit of 1.20. Which is the loss of the counterparty? 1.20. Buying and selling a put option is a zero-sum game. So if the seller is making money, the buyer is losing, and vice versa. Okay. So what happens is that you take this graph and you invert it. You have this graph which is turning around the x-axis. Unfortunately, I don't still have a three-dimensional screen. I've been striving for that for years at Bocconi. We have improving, but not to that level. But the intuition here is that the graph that finally I have is this one, which is just the inversion upside down of the graph of the long put. Is that okay? Now, when you look at the delta, what you're capturing with the delta is that if you go and calculate which is the slope of the tangent line exactly in this point, the slope of the tangent line is 0.5. And this is absolutely correct. So if you just approximate linearly the two graphs, you have exactly the same slope. Super correct. Which is the small problem that just a linear approximation doesn't capture? Is whether the P&L is concave or convex. And the fact of being convex or concave is not just a geometric curiosity, it means something very clearly economically here, which is the following. Think about the case of the call. So imagine the current price is here, okay? In which case do you lose money with the call option, if you are long a call option? If the price increases or decreases, the price of the underlying? If it decreases, okay? Correct. Now, if the price of the underlying decreases, so you move in this direction, what is happening to the delta? What is happening to the slope of the orange curve if you move towards the left? Is the slope increasing or decreasing? It is decreasing. So when you lose at a smaller and smaller pace. You are bullish, you were wrong because the market is falling, but you become less bullish automatically when the market is falling, okay? What happens instead if the price moves up? If the price moves up, the slope of the curve goes up. So you're becoming more bullish precisely when the market is rising. Is that okay? This is structural in the fact that you have unlimited profits and limited losses. To have limited losses, you must be losing slower and slower when you lose. Is that okay? Instead, in the case of the put option, the big difference is that when the market drops, you become with a higher delta precisely when the market is dropping, which is when you would never want to be with a higher delta. Is that okay? Because you're losing faster and faster. And on the other hand, you are making money slower and slower if the market moves up. Because the market is moving up, but your delta is decreasing. Have I been clear? What can we say therefore about this? First, if you look at the sign of the second derivative, so to understand where I'm gamma positive, gamma negative, look at the case of the long call. The second derivative, if I look at the shape of the orange curve here, is positive or negative? Remember when you were studying parabolic functions a couple of days ago? In which of these two cases do you have a positive second derivative? The first, A or B? A. Okay, here you have a positive second derivative, here you have a negative second derivative. So clearly here you have a positive gamma, because it's basically U-shaped, it's a convex function. Here you have a negative gamma. Is it fine? And the intuition that we can give is that having a positive or negative gamma means that if with the positive gamma you lose slower and you make money faster, with the negative gamma is the opposite way around. Okay? Now, let us look quickly at the comparable position of short call, long put. Let's say long put option at the money put first, and then short at the money call. Just to understand super quickly what is going to happen in terms of second derivative. This would be the profile of a long put, and this would be the curve. If you consider the case of a short call, you have this type of profile and this type of curve. Now, if we look at these two graphs, which is the conclusion that we can draw in terms of the sign of the gamma? Take your 20 seconds to think about it. Think in terms of positive or negative gamma in the two cases. In which of these two are you gamma positive? You have a U-shaped function in the long put or the short call? In the long put, correct. So here we are positive gamma, and here we are negative gamma, okay? So what you can see is that you are gamma positive whenever you are an option buyer. Doesn't matter whether it's a call or a put. In both cases, if you're long a call or long a put, you are positive gamma. Instead, you are gamma negative when you are an option seller. If we want to be a bit crude, the idea is that being gamma positive means that the curvature plays in your favor. And this systematically happens whenever you are a buyer, because it's a consequence of the fact that you have a limited loss and a limited profit. If you are a seller, meaning that you have a limited profit and a limited loss, the curvature is playing systematically against you. Have I been clear? So you are negative gamma. Is this fine? All right. Now, next step. The next step is that when you look at the gamma, one thing I've learned, not the first year I was teaching this stuff, but shortly after, is that when you talk with the gamma to people outside the classroom, you can have two very different ways to think about gamma. One is the one which I call the trader's view, and the other one is what I used to call the risk manager's view. The risk manager's view is the view that you typically find more on handbooks, which is thinking about gamma as the second derivative of the change in the market value of the option relative to the price of the underlying. Let's say simply as a second derivative, okay? So the idea behind the risk manager, if you want, is the following. I'm getting back 1 second to the formula I was writing earlier. I want to see what happens to my portfolio if I have, say, a big shock of the price of the underlying. The intuition is, if I use a second order expansion, I estimate it better than just with the first order expansion, okay? So I do not approximate just linearly what's happening to my portfolio, I use the second derivative, okay? That's the intuition. We are going to discuss that later on also with an example. But when you talk to the trader, if you think about the gamma in this way, he's not understanding you, because he's seeing the gamma as the first derivative of the first derivative. So the first derivative of the delta. If you think about it, the second derivative is calculated as the first derivative of the first, okay? So he looks at the gamma as the first derivative of delta, where the intuition here is that gamma is seen as the way to approximate which change you can have in delta when the price of the underlying changes, okay? So here you can write literally that gamma is equal to the partial derivative of delta relative to an infinitesimal change in the price of the underlying, or as approximation, the gamma approximates the ratio between a discrete change in delta and a discrete change in the price of the underlying. I would like to spend a few minutes in explaining this view of the trader, which is typically a bit less explained than the second one. Let's say we have the future trading at 120, and we have a call option strike 121, which as a consequence is in, at, or out of the money. Typical story, is 121 a good price to buy, since it's a call, when the future trades 120? No. So it's out of the money. And, okay. And consequently, the delta is going to be smaller than 0.5. Let's say I have a delta of 0.4, okay? Now, let me add also that I know that the gamma is 0.1, okay? Now, starting from this situation, imagine we have a case in which the future drops to 119. The first question I'm asking to you is, in this situation, should the delta increase or decrease? Think about what happens to the moneyness of the option. Is the option becoming more out of the money or less out of the money than before? More out of the money, correct. So the delta should be decreasing. It's going to be more towards zero than it was before, okay? So I should expect a lower delta. However, with the gamma, I can be more precise and say exactly what the delta is going to be, more or less. Why? Because if gamma is approximating the change in delta divided the change in the price of the underlying, it means that the change in delta is approximately given by gamma times the change in the price of the underlying. It means that here, in which I have a change in the price of the underlying of -1, because the price is dropping from 120 to 119, I should expect a change in delta equal to 0.1 times -1. So a reduction of -0.1 in my delta. Have I been clear? In other words, I can say that my delta is 0.4 and I expect to have a delta around 0.3. Have I been clear? Now, at this stage, we've understood how it works. Still, the feeling is fine, but it's a nice curiosity. No, I would look at the software, see what happens, fine. Can be 0.2, 0.3, 35, who cares? Let me make one step further. Imagine when the future is trading 120, you have in front of you two traders with these two portfolios. First of all, for both traders, the delta is equal to +4. And the simple question I'm asking you is, if you see these two guys with a delta of +4, it means that these two guys are bullish or bearish on the market. They are bullish, correct. Now, a typical idea that we tend to have since we start thinking about trading, which in my case was around 26 years, in most of your cases is going to be probably around 5, given that you have already decided to come to finance very early, is that a bullish guy is somebody who's happy if the market goes up, and if the market goes up a lot, he's happier than if the market goes up just by little. That's what we typically associate with being bullish on the market, okay? Now, imagine we add one information, which is the gamma of the two positions is -2 in the first case and -20 in the second. So again, on a qualitative standpoint, we would say, fine, positive delta, negative gamma, so these two guys are mostly selling options, that's why the overall negative gamma, but not a big difference. Let me add one thing. What is going to be the delta, the new delta of this position, if the future raises to 121? So the future is starting from 120. Imagine the future increases to 121. Which would be the new deltas of portfolio 1 and 2? Take 20 seconds to think about it. Which would be the delta in the first case? The idea is that the change in delta should be given by gamma times the change in the price of the underlying, okay? The change in the price of the underlying, which here is +1. So for the first portfolio, I would have a change in delta of -2, which means that starting from 4, I end up with a delta which is +2, okay? In a similar way, for the second portfolio, I would start with a positive delta of +4, and I would end up with a delta of -16, because I would have a change of -20, okay? Let me add another thing. So for portfolio 2, I start delta positive, end up delta negative. Imagine I ask you another question. Imagine the path of the price moving from 120 to 121. There must be some point in between 120 and 121 where the delta actually becomes 0. Can you tell me at which level the delta is supposed to become 0? Think about it. To have a delta of 0, you need a change in delta equal to what? -4. Okay? So you must solve an equation in which this is -4. You have a gamma of -20, and your unknown is the x, which is the change in the price of the underlying, such to produce a delta of -4. Which is the solution? Is 0.2, 0.20. Okay? This means that if you think about it, in the range between 120 and 120.20, you are delta positive. Over 120.20, in these 80 cents of price increase, portfolio 2 had which sign of delta? A negative delta. Because from this point onwards, the sign of the delta has changed. Is that okay? So, first intuition, the idea that for the trader, the gamma is mostly seen as the speed at which my delta changes is a bit clearer now, because here the sense is for this trader, the point is locally I'm bullish, but just if the market goes up by little, I become bearish, okay? And in a second, my position is switched in the other side. Incidentally, the most worrying case is not if the market goes up, it's clearly if the market goes down. So it's true that this guy is bullish, saying that overall it's better if the market goes up than down, because think about what happens if the market goes down. If the market went to 119, which would be the delta of portfolio 2? If we have a -1 change in the future, delta becomes 24, okay? So he would become tremendously bullish exactly when the market falls. For instance, these are situations in which if you are a trader, depending of course on which is the size of the position on the market and the like, but if you have a super strong negative gamma and the market goes down super quickly, or you have a crash which was not prevented, well, then it's a serious problem. Imagine there if the market goes down by 2 because there's a truly bad news which the market did not expect, you're going to have a super large increase in the delta when the market crashes. And I still remember once, many years ago, in which your students say, well, where is the problem? I do delta hedging. Theoretically, fine. Think about what this means if the market is crashing for portfolio 2 making delta hedging. If the market goes down by 2, portfolio 2 starts having a delta of 44. Delta hedge means doing what? If you have a delta of plus 44, making delta hedge means that you have to sell 44 contracts. Fine. Where is the small problem? That in order to be able to sell 44 contracts, one thing is needed in nature, which is somebody who buys 44 contracts. Because otherwise you are somebody desiring to sell, not selling. In order to sell, you must find something that buys 44 contracts. If the market is crashing, that you find somebody willing to buy 44 contracts when the market is still crashing is unlikely. When the market has ended crashing and you have had all your possible losses, then somebody will eventually buy. But not when you need it most, okay? So the point is, having the sense of how quickly my delta is changing is tremendously relevant from a trader standpoint. And that's why they mostly see the gamma in this way. Have I been clear? Incidentally, minor thing we are going to discuss later on, as a gut feeling for portfolio 2, given that if the price moves up by 1, you are making money for the first 20 cents of increase, and then losing because you are delta negative and the market still goes up for the other 80, which is your feeling about whether overall you lost or made money for portfolio 2? Overall, what do you think is going to happen here? You made or lost money? If you made money for the first 20 cents of increase and then you were losing for the second 80 cents of increase, overall, you would expect you would have lost money, okay? Which is what you're going to test later on. Whereas instead, we would expect to make money if the increase is sufficiently small, that for sure we make money if the increase is less than 20 cents. Maybe we make money if the increase is slightly more than 20 cents, but not too much more than 20, okay? That in terms of rough intuition, this is what we would be expecting. All right. Now, on the trader's view, there is only one point that I have to add, which is the following, which is that when you look at equity market positions, typically you are not going to find the delta and the gamma, but more frequently you're going to have, in terms of measures that are on your screen, delta 1% and gamma 1%. Why do you have them and what is the meaning? The point is simple. Imagine that you are trading positions, say, on 2 stock indexes. Imagine that I'm just inventing indexes as an example. You have the Euro Top 100 and you have the Top Stocks 50. Imagine they are ideal European stock market indexes. And imagine that the, so to say, pure delta for these options, for the option positions that you have on these stock indexes, is equal to, say, 20 and say is 3.4, okay? If you just were looking at the pure delta, you would tell me the first position is more exposed than the second one, okay? But now let me add one piece of information. Imagine the level of the index of the two indexes is such that the first index is trading at 500 index points, whereas the second index is trading at 40,000 index points. You know that every index has its own measure. There are some stock indexes that trade at 2,000, some at 20,000, some at 50,000, some at 800, okay? Depends on where you set the initial starting point of the index, and whether it's 100 or 1,000, which is totally arbitrary, okay? Now, if these were the pure delta, this would tell you what? It would tell you how much money you make if the underlying goes up by 1. But for the first index, going up by 1 from 500 to 501 is a much larger move than for the second going from 40,000 to 30,001. Is that okay? The same thing happens for the stocks. Imagine you have stock alpha and beta, where the first one trades at 40 and the second one trades at 4. An increase of 1 is a plus 2.5% for the first stock and the plus 25% for the second. Doesn't make any sense to compare this delta, which are relative to a 1 which is so different. Is that okay? So what you look is what is delta 1%, which is the change in the market value of the position if the underlying goes up by 1%. Okay? So essentially, what happens here is that delta 1%, for example, for the second position, would be saying, I react 3.4 for every single point increase of the index. How much is 1% increase? Is 400 index points. So my delta 1% is 3.4 times 400, okay? For the second index, which has a pure, if you want, delta of 20, what is a 5% increase is 5 points. Is that okay? And from here, you understand that overall, you are more exposed to the second one than to the first. If the second one goes up by 1%, then there is a bigger impact. So the idea is that you compare the positions by saying, what is a 1% change? How many index points, how many euros, depending on what the underlying is. And you take into account directly a 1% change. So for the two stocks, here you will model what happens if you have an increase from 4 to 4.04. And here you see what happens if you go from 40 to 40.4. Is that okay? This is comparable. Otherwise, you have no idea of what is your true position. Gamma 1%, similarly, is how much my delta would change if I had a 1% change in the underlying. Same story. So for exercises, I would mostly 95% of times work on pure delta and gamma with options on the bond futures. Occasionally, there might be something on this, but the key point is simply understanding that the simple idea is just that I want to have something which is comparable, because otherwise, the pure delta, the pure gamma with prices which are crazily different would not be possible to be matched up or added, okay? That's the point. All right, now the next step that we have to do is looking at getting back to the risk manager's view. So in the risk manager's view, the idea is that I can use the formula taken at the second order Taylor-Maclaurin expansion to try to model what happens to my option position. I don't know at which point you are with Andrea, meaning Andrea Sironi in the risk management course, but if you talked about a delta gamma approximation for option, for instance, that's the story. I don't know whether you have discussed market risk already, now you're at credit risk directly, or you're still talking about market risk, value at risk? Market risk, all right. But maybe he would mention, I'm not totally sure, but if he talks about a delta gamma approximation for option, is exactly using this equation. And the simple exercise we can do just to understand how it works is getting back to the story of the two portfolios here, taking portfolio 2, where we had the intuition of what? That if we have a 1-point increase, we are expecting to lose, okay? If the increase is sufficiently large. If instead you had an increase from 120 to 120.10, which is still in this range, intuitively we would expect to make money, because it's an increase in which I was originally delta positive. I've always been delta positive while the market was going up, so I should make money, okay? How can we possibly check it? One way to check it could be to use this formula. So what I'm going to compare now is which would be the result of the portfolio comparing case A, which is the future going from 120 to 120.10. So I have just a small change of 10 cents, as opposed to case B, in which the future goes from 120 to 121 with a change of +1, okay? What happens in the first case? In the first case, the effect which is given by delta, let me rewrite here which were the delta and gamma of this portfolio. So I had the delta of +4 and the gamma of -20. With the delta equal to +4, which is going to be the effect given to delta? So if you want, let's say this is the delta effect, and this is the gamma effect. The delta effect would be simply equal to 4, which is the delta, multiplied by 0.10, okay? So based on delta only, I would expect to make 40 cents, okay? Now, here we are gamma negative. So the idea is that the curvature is playing against us, which means that we know that we are not making as much money as delta would tell us. We're making for sure less, okay? Why is this the case? Because gamma divided by 2 here would be -10, okay, -20 divided by 2, which is multiplied by 0.10 squared. This means that delta effect is 0.40, which is the size of the gamma effect here. 0.10 squared is 0.01, and as a consequence, what I lose due to gamma is 10 cents, okay? So I'm not making 40 cents, I'm just making 30. Have I been clear? And incidentally, one reason why I do this example is also that you can capture one idea. The fact that I have gamma divided by 2 multiplied by delta p squared, the fact that this delta p squared means essentially 2 things. First, the sign of the gamma effect only depends on gamma, because delta p squared is always positive. So whenever gamma is positive, I'm making more money than what I would guess based on delta. Whenever gamma is negative, it's going to go worse, okay? But the second thing is that since I'm taking delta p squared, if delta p is small, delta p squared is particularly small and negligible. Instead, if I have a large delta P, it's the other way around. Okay? So for a sufficiently large change in delta P, change in P, the gamma effect would clearly easily dominate even the gamma story. It's a matter also of what are the numbers, of course, clearly. If I had a gamma of -20 and the gamma of 4 billions, delta would still dominate, okay? But in relative terms, the larger is delta P, the faster it becomes super important, the gamma effect. Let me see what happens in the second case. Same story. The gamma effect is 4 times the change in the price of the underlying, which is 1. The gamma effect would be -10 multiplied by 1 squared. Despite the growing complexity of mathematics, which is implied in this case as opposed to the previous one, we probably tend to agree that here I'm going to have a strong negative effect, okay? Because the very high gamma combined with a sufficiently non-negligible change in P implies it's much more what I lose on gamma than what I make on delta. Have I been clear? So for instance, this is a quick way to check what the intuition that we had originally, the trader's intuition that for a sufficiently large increase of the price, things would not have worked, was true. Is that fine? All right. Now, while until a few years ago I would have going on with Greeks, I've learned that it is nice to anticipate one thing which is going to be related to trading strategies that we're going to see starting next week. But just to show you that, for instance, the portfolio that we've seen here that changes the sign and the like is not something mystical requiring hundreds of options, exotic, weird, bizarre options altogether, but can be obtained potentially even with super, super simple elementary trading positions. So let me anticipate something that we're going to discuss later on. And of course, when we're going to reconsider the argument, I'm going to be faster, which is asking you the following. Imagine you combine these two positions. You sell a call option, strike 120.20, and you sell a put option, strike 120.20. Imagine the future trades at 120 exactly, okay? Let us try to draw the P&L of the combined position of these two short options. First of all, looking at what happens at maturity, and then we're going to see also what happens before maturity. Now, first, if I sell the call option, I would have a profile with this pattern. Until 120.20, I earn the premium. Over 120.20, I start having the other part exercising, and potentially I can lose more and more, okay? So this is the short call position, okay? Now I have to draw the graph of the short put. Now, if you want to be nasty with your relatives when explaining today's class tonight, you can ask them abruptly, as I'm doing with you, but not because I want to be nasty, is the put option going to be worth the same as the call option now, more or less? Think about it. The future trades 120. The two options have a strike 120.20. Which of the two is slightly more valuable than the other? At 120.20, it would be a good price to sell. So the put option must be in the money. By the put call parity, should trade 20 cents higher than the call, okay? So make sure that every relative is having a line here which is slightly higher than the other one, because the put has a larger premium. And then, of course, below 120.20, you start suffering the exercise of the counterparty again, okay? Now, first step of the story is what is happening at maturity if you combine a short call and a short put. If you combine the two, which is the single level of price at maturity for which you have the highest maximum profit? Is when you sell both options and neither of the two is exercised, so you get the sum of the two premia. This happens for which level of price? 120.20, because in this point, neither the put nor the call is exercised. So you clearly have a peak profit here for any final level of the price, which is different from these. Either the call or the put is exercised, so things start to go worse. For instance, for higher prices, this is what happens. You have a line going down with a minus 45 degrees orientation, which is essentially the same one of the short call, just taken up by the price, the premium of the put, okay? And specularly, this is what happens if you have price below 120.20, because the put option starts being exercised, so you start to lose again linearly, exactly with the same slope as the simple put. Have I been clear? This profile that we have obtained is one specific and very popular trading strategy, which is known as short straddle. You have a straddle whenever you buy a call, buy a put with the same strike, or sell a call, sell a put with the same strike. If you sell both options, it's a short straddle. If you buy both options with the same strike, you have a long straddle, okay? So if you have a long straddle, I'm not redoing the graph second by second, but pretty clearly you are going to have this type of profile, where this point is the strike price that you have chosen, okay? This is what you have if you buy a call and buy a put. In case you wanted to try, there is remember a list of prices that I gave you of options on the Bloom futures. You take two and you make the sum, and you see that this is what is going to happen, okay? Now, the next step is the following. The blue line that I've drawn is the value of the position at maturity, not the P&L today. If I wanted to add the P&L today, ideally, I should not be adding up to broken lines of the P&L at maturity. I should add up to curves. So, intuitively, I should add a short put and a short call where the value should be a curve working in this way. I should add up the two orange curves of the short call and the short put. Is that okay? First and quick intuitions, when you look at these two, are they both convex, both concave, one convex and one concave? They are clearly both concave, okay? So they are both gamma negative positions, and if you add them up, we are going to have a strongly gamma negative position, clearly. What is going to happen here is the following. I would have something that for very extreme levels of the price will start getting closer to the blue line, but for sure it is going to have a maximum, a peak, precisely at 120.20. Why this function, which is the P&L, must have a maximum at 120.20? For a very simple reason. Because the slope of the P&L there is the delta. Think about what happens if the future trades at 120.20. If the future trades at 120.20, how would you classify the two options between in the money and the money out of the money? If the future traded 120.20, they would both be at the money, okay? So you would have a 0.5 delta on one, a minus 0.5 delta on the other one. You are taking 0.5 times minus 1 for the call, minus 0.5 times minus 1 for the put, and the sum is 0. Have I been clear? Instead, for instance, when you are at a future price equal to 120, think about the call and the put in terms of moneyness, so in terms of whether they are in, at, or out of the money. When the future trades 120, which of the two options is in the money? 120.20 is a good price to sell or buy? To sell. So the one which is in the money is the put. And the call is out of the money, okay? So if you think about the overall delta, the put can have, say, a delta of minus 0.55, so slightly larger in absolute value than minus 0.5, which is multiplied by minus 1 because you sell. For the call option, you have a delta which is smaller than 0.5, say you have 0.45, for instance, multiplied by minus 1. Overall, do you have a positive or a negative delta? Overall, you have a positive delta, okay? If you take instead a price just slightly higher than 120.20, think the price is 120.40, okay, so just above. With the future at 120.40, 120.20 would be a good price to buy or sell. The future trades 120.40, and you can either buy or sell at 120.20. It would be a good price to buy. So the one in the money would be the call option. You would have the call option in the money, the put out, and you have something just slightly inverted. You would have 0.55 times minus 1 for the call, minus 0.45 times minus 1 for the put, and overall, this would imply being slightly delta positive or slightly delta negative. You would be slightly delta negative, okay, because the call wins, and the call here is multiplied by minus 1, so it's a delta negative position in your portfolio. Have I been clear? This is just to show that the kind of behavior we were describing earlier can be obtained with something as simple as two options. Clearly, not with a delta of +4 and a gamma of -20, but if you short 30 straddles, if you take this position with selling 30 calls and buying 30, and selling 30 puts, it can possibly, absolutely possible to have the kind of risk that we are describing earlier. So it's super simple. It's not something requiring some weird magician taking some crazy position on exotic options. Is that fine? And clearly here, the point is that just a small change in the price can alter completely your exposure. You can also see that if the price drops, the slope here is increasing. So this position is becoming more delta positive precisely what you don't want if the market drops, okay? It's the effect of being gamma negative. If you think about it, also from a trader standpoint, when you say that the change in delta is equal to gamma times the change in the price of the underlying, from here you understand super simply that from the trader standpoint, being gamma negative means that the delta changed in the most horrible direction you can think of. Because if gamma is negative, means that if the price goes up, you become less bullish or more bearish, which is not what you want if the market is going up, okay? And vice versa if the market is going down. The market is going down, you are gamma negative, you become more bullish, the least thing you would like. Is that okay? All right. Now there is just one small piece remaining, which is understanding how gamma behaves, because we've seen that gamma is positive when you buy, negative when you sell. We still don't know when you have a high gamma or a low gamma. This is the part which is missing. Now, in order to understand that, what we can do is the following. So, the intuition is simpler if we look at the option on a Bund future. And what I'm going to do with this Greek and also with theta is to give you the intuition about how it works for the option on the Bund future, which is far easier, and then show you, but just on the graph, what, due to how the formula works, where I don't have, unfortunately, a fantastic intuitive explanation, which is the slight difference that you have in the case of options on stocks, okay? But if you understand at least super well and intuitively how it works here, it will be very easy to remember also the other one. If you see the two graphs with no intuition whatsoever, it's going to become close to impossible to remember. The idea is the following. When we have the value of the option made up by time value and intrinsic value, gamma is graphically what? Is the second derivative. So it's the measure of the curvature here, okay? So a larger gamma means a higher curvature. Or if you want, if you are a trader in your heart, a larger gamma means delta changing faster. It means that you move left or right, and in a small amount, there is a bigger change in the slope, okay? Which happens if you have more curvature. So it's the same story seen in another way, okay? First point that I'm making is the following. What is happening from the point of view of the behavior when I get closer to maturity? When I get closer to maturity, this curve is systematically going down, okay? So imagine this black dotted line is the situation where, say, 1 month has passed to my 2-month option. And imagine I have another time passing, and so I get closer and closer to maturity. And this is the blue line. Which is strictly lower than the black dotted line, okay? Now, the first intuition I want to give you is the following. If you look at the 3 graphs all together, and you have to say whether there is more curvature in the region B where you are at the money, A where you are out of the money, or C when you are in the money, when do you see a larger curvature? Consider, for instance, if you want, consider super extreme examples. Imagine the future is trading 140, okay? Imagine the future trades 20, crazy. Let's say for a second the future trades 20, okay? On a 3-month option with a 7% volatility. Use the black model that we discussed last time with your mind, using the natural cumulative functions that you have used a lot in the first semester without calculator, okay? If the future trades 40, you have a 7% yearly volatility, and the option exercise if at maturity is larger than 140, which is there is neutral probability with 7 digital numbers of digital decimals of approximation that the option can be exercised. From 20, you must go to 140 in 3 months with a 7% volatility. Any guess? 0, okay? Probably for 20 decimal digits, okay? Low volatility, short amount of time, crazy amount that you have to increase. If the price moves from 20 to 21, which is going to be the price of the option? At 20, the price of the option was 0. If the future goes to 21, everything else being equal, the option price is going to be 0. You're getting faster and faster with exercise by using black without calculator. That's fine. Imagine the future from 21 goes to 22. Which is going to be the price of the option? 0. Wonderful. Now, by comparing 20 and 21, you can tell me which is the delta of the option when the future trades 20. if going from 20 to 21, you had no increase in the option value, means that your delta is 0. Okay? If from 21 to 22, you have no increase in the option value, means again that the delta is still 0. Have I been clear? If the delta is not changing from 20 to 21, which is your gamma? If gamma tells you how quickly delta changes, gamma is 0. If you think about it graphically, now, unfortunately, 20 is completely outside the scale here, but it's in a point in which I'm so on the far left that the curve is lying on the x-axis. And the curvature of the x-axis, if properly drawn without having had an aperitivo at Navigli or in other conditions, should be 0. Okay? The same happens if you are on the other extreme and you have the curve which is already lying on the payoff line. The curvature is 0 on the extremes. Is that okay? So intuitively, you must have more curvature in the middle area. Intuitive. So as a first intuition, when you have gamma, and here the typical way in which it expresses is looking at the ratio between the price of the underlying divided by K. So 1 is where the option is at the money. Okay. 1.1, for instance, would be having a future that trades 10% higher than the strike. 0.9 would be the future trading 10% lower than the strike. You would expect to have a gamma working more or less in this way, with a curvature which is more pronounced at the money, and decreases, and you get more and more and more out of the money or in the money. Have I been clear? First crude intuition. Second intuition is the following. Imagine you are exactly at the money and you get closer to maturity. Let me add even another line, which is when you're tremendously close to maturity, very few days left. So time value is 0 in many points. And there is only a very small region here in which delta is 0 on this extreme and 1 on the other. Intuitively, when you move from B1 to B2 to, say, the point here, B3, and you get closer and closer, is curvature increasing or decreasing? Curvature would be increasing. There is a smaller and smaller price range in which the delta from 0 becomes 1 intuitively. Okay? If you want a way to capture the idea and remember it easily, think about this point. The curve of the value of the option is eventually going to become a broken line. Okay? Now, imagine that as it happened until a few years ago, Bocconi offered plastic bars outside of my classes so that at the end of the class, anybody who was angry because he or she has not understood one point could come up of the class and satisfy his rage by breaking one plastic bar, okay? Due to sustainability issues, this practice stopped a couple of years ago, as you can easily imagine. Now, in this situation, if I ask you, in which point is curvature maximum? 1 second before you are breaking up the plastic bar, where you keep the bar on the extremes or in the middle. The curvature is maximum exactly in the middle when it's going to be broken. And the curvature is maximum 1 second before you actually break the plastic bar. Okay? After that is broken, but the point in which there is the greatest curvature is 1 second before the breakup. Here is the same story. So gamma is going to behave in this way. It's going to be reduced on the extremes and peaking at the money when you get closer to maturity. It's peaking at the money because it's the point in which you have, in a short amount of time, moving from delta 0 to delta 1. And instead is decreasing on the extremes. It can be easily seen here, because when you get closer and closer to maturity, in a region in which the option is no longer exercisable, for instance, the curve has already become practically flat. And if it is practically flat on the x-axis, the curvature has disappeared. Is that okay? If you want to think about it another way, what is producing the curvature is mostly time value. If you no longer have time value, you no longer have curvature. Is that clear? That's the intuition. So if we look at the actual graphs, this is on the set of slides that I've posted on Blackboard. And of course, I'm following that a bit also in the examples, but which is fine, maybe with slightly different examples, but I wanted to reason step by step here in class. These are the graphs. First, for a Boone future option, this one. So the blue one is the one with 3 months to maturity. The dotted one is 2 weeks to maturity. And you can see that in case of the Boone future option, we have this fantastic, perfectly symmetric graph, exactly identical to what we were looking at. Is the easiest one to understand. What happens in the case of European option on a stock is pretty similar, with only 2 differences. Well, only one difference. So when you are close to maturity is the same story. So the behavior of getting closer to maturity is the same, and also you see that the peak is extremely close to the at the money point. The only difference is that before maturity, the peak is slightly towards the left. Okay, so the peak is close to at the money, but typically for a price which is slightly slower than that. But you're not too wrong if you say that the peak is at the money. Say, for the first contract, you say the peak is at the money, full stop. For the second case, you say it is close to at the money, and it may be nice to say that it's slightly below at the money, but just by a little, okay? The closer it gets to maturity, the closer you have the peak exactly at the money, which is incidentally where it matters most. So the big problem is when you sell an option which is unluckily at the money when you're close to maturity. That's a problem. So when it's problematic, typically is when you are at the money and close to maturity. And there it's at the money for any contract, okay? Just a quick check to see whether we start being quick enough in reasoning on that. Imagine I tell you, you have the future trading 125. You have a position in which you sell a call strike 125, you buy a call 128. Are you gamma positive or negative? Start by asking yourself which is the sign of the gamma for each position. Is the first position gamma positive or negative? Negative because we sell. The second one, positive because we buy, correct. Now, which is the gamma, which of the two has the highest gamma? Gamma is maximum where? Where the option is at the money. So which of the two has the largest gamma in absolute value? The first one. So overall I'm gamma negative, okay? And incidentally, for instance, if the future were 126, we would still conclude that the gamma is negative because neither of the two is at the money, but the one that we sell is closer to at the money relative to the other one, okay? At 127, I would start having the one that I buy closer to at the money, and I would start being gamma positive. Is this okay? All right, that was the story. All right, next step is theta, which is the derivative relative to time that passes. Here I'm going to be quicker. But the intuition is, well, first definition is that theta is literally the partial derivative of the market value of the option relative to time. And therefore, it approximates the discrete change, the ratio between the discrete change in the market value of the option relative to the time that is passing. So you can say that there is a theta effect which is equal to theta times delta t, okay? With theta, The problem is there are two elements to which you should be very careful about. The first one is the unit of measure. If you are working in a desk and they tell you I have a theta of 0.13, the question is to understand whether it's a large or a small number. The first question is understanding whether it's measured having delta t measured in days or years. So the problem is how you measure delta t, because of course a 0.13, if delta t is measured in years, is totally negligible. 0.13, if it's measured in days, is just a bit more, okay? Usually, in most handbooks, you see delta t in years, but in most front desks, you see delta t in days, clearly, for intuitive reasons. It's much better to have a number that tells you how much money I make or lose if I move from today to tomorrow. A second point is more tricky, which is the sign of delta t. Very simply, moving from today to tomorrow is a positive or a negative delta t. Depends on how you reason. Because you can have two possible ways of thinking. One is, say, tomorrow the universe is 1 day older, so it's a delta t of +1. The other alternative is that you can say, I have a 90-day option today that tomorrow is going to have 89 days of remaining time to maturity. If you consider the remaining time to maturity, moving from today to tomorrow is a delta t of -1, okay? Even when you look at option handbooks, in some cases, the time to maturity of the option is written as big T minus small t. And here you refer the difference between the two dates. In other handbooks, it's just T, which is simply time to maturity. Clearly, if you have the formula where you have T minus T or T, the derivative changes the sign. Very simply, okay? So the typical standard, but when you have a software, please check it first if you have to trade on options, is to say that when you are theta negative, it means that as time passes, you lose money, which is the typical position of the buyer. And I add usually because for the buyer, in 95, 97% of cases, the theta is positive. For some contracts, such as options on stocks, there can be cases and parameters for which you have the opposite sign of theta, but only for extreme prices, typically. Instead, if you are theta positive, it means that as time passes, you make money. And this is the typical position of the seller. So clearly, the idea, if you think about, for instance, the buyer, when you have a theta negative, you lose money, so this is negative, means that the typical assumption is that moving from today to tomorrow is a delta t of +1, okay? Incidentally, the reason why I spend a bit of time on this that could appear to you boring is probably a personal shock / experience, depending on how you want to call it, because many years ago when I started teaching this stuff, I became friend of a trader, important trader in Milan, that at a certain time he changed the bank in which he was working. So on the second day he was in the new place, he invited me to come to the trading room, and he was super happy to have been promoted to a larger bank. And he showed me, look, I inherited this portfolio from the previous guy who was running the option desk. And it's a wonderful portfolio, and gamma positive, theta positive, I make money on the curvature on time passing. And they say, look, probably it's not working. Because the typical name of the game in the options is that if you buy options, you are positive gamma, so curvature is in your side, but you are negative theta, so when time passes, you lose. If you sell options, it's the other way around. The good part of the story is that if time passes, time is in your favor, but curvature is against. After a quick check, he realized that the problem was that the way in which theta was measured by the software was different from the previous bank. So his theta positive meant instead that he was losing money as time passed. Luckily, he discovered that on the second day of work, not after two months. So I won a dinner for that, which was the incidental nice part of the story. But after that, I said it's worthwhile to spend 2 seconds about being sure about how your software is working. Now, what is the next step that we have to do is understanding a bit how theta behaves, how theta works. Again, in this case, I can explain you what happens for the option on bond futures, which is simpler, and then you can get a perfect picture. And then the case of options on stocks, European options on stocks, it's something similar. I'll show you in which sense, but theta can vary quite a bit from one contract to another one. So it's relatively similar, but with some differences from contract to contract. What can we say for options on bond futures, which is going in any case to be the driving force behind theta? The intuition is that theta, so the change in the value of the option due to time, can be seen by looking at how this curve moves. When time passes, the time value decreases for any possible level. So when time passes, we know that this curve would be falling down gradually, okay? So every day, I find a curve which is lower and lower and lower, okay? The idea is that theta is the speed at which I lose time value, the speed at which the curve is falling intuitively. Have I been clear? Now, if this intuition is roughly clear, imagine I want to make the graph of theta relative again to the ratio between the future and the strike. So again, 1 is the at the money case. Imagine I ask you the following. Is theta going to be higher when I am at the money or when I'm out or in the money? How can we answer? We can have this intuition. Imagine for a second I wanted to draw the graph of time value alone. So not the sum of intrinsic time value, but only time value. For instance, if I were on the initial black curve, as long as I am out of the money, up to here, time value would be coinciding with the total value of the option, okay? Because when I'm out of the money, there is no intrinsic value, and the whole value is purely time value. Have I been clear? And when I am exactly at the level of the strike price, I have the maximum level of time value. Is that fine? Now, as I move on and become in the money, time value here is explained by what? The chance of future exercise or the chance of abandoning the contract? When I'm here in the money, the chance of abandoning the contract. And as a consequence, abandoning the contract becomes more and more unlikely as the price goes up. So time value would be systematically decreasing. The graph of time value only would work in this way, because the difference between the curve and the line is shrinking and shrinking and shrinking as I move up. Have I been clear intuitively? Okay. Now, let me make this question to you. Consider point A, point B, which is at the money, and point C. Which is the time value that you have in A, B, C at the maturity of the option? It is 0 in all 3 cases, okay? In which of the 3 points you had more time value to lose within the maturity of the option where you were 3 months earlier? In B. This implies that in B you have lost time value faster. Because if at the end you have a time value of 0 for all cases, and you had much more time value to lose in B, it means that you must have lost time value at a faster speed, intuitively. Have I been clear? It is as if you have a rush outside Bocconi with people starting from different distance from the finish line and everybody crossing the finish line at the same time. The one starting more distant from the finish line is the fastest runner. Is that okay? So the intuition is that theta should work more or less in this way, with a peak around the ad money. From the point of view of the behavior, when you get close to maturity, there are two opposite things that happen. It's pretty similar to gamma, if you want, because when you are out of the money, imagine I'm very close to maturity, which is the continuous blue line. When I'm here, for instance, I have already exhausted the time value before I'm in the last 2 weeks. So imagine that the option trades, the strike is 140, and this point is 132. When I'm at 5 days to maturity, I have no chances whatsoever to exercise this option. So time value is already 0. Is that okay? When the future trades 148, there is no chance that the option can be abandoned if I only 5 days lasting to maturity. So I lose time value earlier. When I'm in the last period, it has already been lost, and I'm less sensitive to another day that passes. Is that okay? So here, on the extremes, I must have a smaller theta, so less negative theta, or a smaller theta in absolute value, meaning that in the last days, I'm less sensitive to the extra passing of time because everything has occurred earlier. Instead, when I'm at the money, it's the other way around. Think about this thing. Imagine you have got an option strike 140 from your parents, and imagine these two cases. Case one is you have 90 days to maturity, 1 day passes, and the future is stuck at 140. And so you move from 90 to 89 days. Clearly, you lose money. Fine. Second case, the future is at 140. You have 2 days to go to maturity. The future remains stuck for 1 day. Now you have just 1. Intuitively, you lose much more in the second case because the 1 day missing is half of the remaining life of the option. So the effect is stronger when you are closer to maturity than when you are distant to maturity, if you are at the money. So the theta behaves in this way. You have a much more negative theta when you get close to maturity. If we see the graph again, sorry, I went too far. This is the graph for the Bund future option. So exactly, you have a less negative theta when getting closer to maturity on the extreme, a much negative theta when you are at the money. For option on stocks, it's a similar thing, with the only problem that is slightly asymmetric. There is not a fantastic intuitive explanation for that. The only thing I can say is that in this case, when you have an impact, you have an impact of passing of time also on the growth of S. So it's a mixture of the effect of delta due to the growth of S and the effect of pure passing on time value. Keep in mind that what happens is that you have an asymmetry on the right-hand side. Depending on current parameters, you can have either a situation in which it goes this way and becomes negative, or it becomes more positive, keeping a fixed level as it is here. But this depends also on the parameters, for instance, of the dividend yield of Q, whether it's a call or a put. The basic idea, however, is that, again, the ways in which you are most worried about theta is when you are at the money and close to maturity. This is still true also for this contract. This is the case in which you can have a truly high theta, okay? It's less symmetric than the previous case. That's the point. So we finished on that. We are going to do next time, start with Viga, which is the last Greek that we have to discuss, say a few last things on Greeks, and then we're going to start with the trading strategies. Thank you. Incidentally, I will also ask to fill next week, I think you're going to be asked, also the mid-course questionnaire. I typically don't ask you this extra effort, but given that I just see a few of you and there are many people following from home, it's important to get a feeling on how the course is going. Thank you.